nice to be out here in the woods and have a chance to come and talk to you guys a little bit today about science. And this is Wednesday, and holy cow, what is it? It's Sasquatch! Holy heck! Sit. Hi. Sorry, false alarm. It is April Fool's Day. It's Wednesday, April 1st, 2020. Come here, Cora. I thought it was Sasquatch, but no, it's my pup, Cora. And she's out here with us today for science class, so that's kind of fun. You guys remember her when she maybe came into class back when we were learning the 6 life processes, the 4 G's and 2 R's. So I'll let her run around a little bit while we're unpacking some science stuff that we've been going over with this standard on water. Hopefully you guys watched the video with Sabrina yesterday on the water everywhere. So let's get some stuff out here that we can look at and review some of that. It is April Fool's Day, but what's going on in the world is no joke, and so we want to take that seriously, but at the same time do a little bit of learning. And what better place to do it than right out here in the water, in the background. Dry Run Creek. Anything but dry right now. In fact, I had to move my location over here because everything else is saturated with all the flooding that's been going on along the creek here lately. All right, so if we pull out some gear here, I'm not going to really be editing this video much, so whatever happens, happens. If we have a bird fly by or tree fall over, nobody may hear it. That's a philosophical joke there. But that's just nature happening all around us. Alright, look, I even have the expos. Okay, so if you want, you can open up your notes today, and it's the review of what we looked at yesterday with those notes, and this is leading up to an assessment that I'll have you guys doing, just comparing different kinds of water. But if you start with the beginning of the notes, it says percentages are based on 100. This means that if you add up all of the various percentages within a set of data, all those parts should equal the whole. The parts equal the whole. Kind of like numerator, denominator when you're doing fractions in math class. Cross-curricular there. Did you see how we had that go together? So if you look at your various statistics, when we look at Earth is made up of roughly 70 and 8 tenths, or 70.8, or 7.8% land, and oh nope, got that wrong. Holy cow, Mr. Rhines, you can't edit it. I know, I'm just moving on. 70.8 or 8 tenths water, and we have land at 29.2% water, right? Land right here. I honestly thought it would be a lot warmer working down here today, but it's a little chilly, so my hands are a little cold getting them to work here. All right, so when we add up those, the water and the land, this is on Earth. We think of Earth as a globe, and here's the equator and all the various continents. We have 7 continents and all the oceans. So water below land, water above land, water in the sky. Taking all that water and all the soil, land, when we add that up, this is surface, on the surface, this will be 10, 8 and 2 is 10, we regroup, bring that decimal down, 9 and 1 is 10, 10 ones, and then we have 10 tens. 10 tens makes 100%. And so we have 100% of the surface area identified, 70 and 8 tenths of it being water, and 29 and 2 tenths of it being land. So that was the first statistics. It always comes to 100%. All right, let's grab a different colored marker. Got a different colored marker. Quick intermission break with the Cora. Good girl. Good girl. All right, so now let's talk about the water in general. Some of the water is fresh water, some of it is salt water. The other day, some of you were asking the question, or I asked you the question on that one little survey, where does salt come from? We'll be talking a little bit more and more about that, but salt is a mineral, and there are minerals in the earth. So as water is running over the earth, it's picking up minerals out of the earth and traveling it in little streams like this, right here in Dry Run Creek. And so it's picking up little tiny minute pieces of salt and carrying them from here. We know this is the Dry Run Creek watershed. Some of you live down by the Kinnickinnick watershed. And together that all goes down to the Rock River watershed. So there's little tiny bits of particles of various minerals, some of those minerals being salt, and then carrying it from there to the Mississippi on down to the ocean. That's happening in little tiny creeks and rivers and streams across the world. And so it keeps getting deposited over and over and over again into the ocean, and so that ocean content just keeps. Oh, what did you see? Did you see something? So that salt deposits from the land, running off the land into the ocean, just keeps building up, and so that's why the oceans are salty. One of the reasons. Okay, so let's look at water on the earth. On this earth, whoop, bring that right down here. On the earth, we have some of it is salt water and some of it is fresh water. And so the salt water is 97.5%, you see in your notes there. And then the fresh water is just 2.5. Only 2.5% is actually fresh water, like this creek right here that we have behind Mr. Rhines. When we add that up, holy cow, look at this again. I can't believe it, Mr. Rhines. I know, 100%. So it's identifying all the water in the world. 97 and 5/10 of it is salt, and 2 and 5/10 of it is fresh. Now, let's talk about, out of all the locations, you're like, where is all of this stuff, Mr. Rhines? Well, it's in different places. If you're looking at your notes again, I'll go to a different color. The third section of your notes there, I think it says oceans, it says ice caps. That's like on Arctic or Antarctic. That also includes glaciers. Groundwater, we've talked about that. That's underground in our aquifers. Surface area, that's like our lakes, rivers, creeks like this right here. And then in the atmosphere, that's like the question you answered right before spring break, like what is the difference between, or how do they interact between water and air? And you know, when it's a dark surface, it heats up the air. When it's a light surface, it reflects, and maybe it's a little cooler. And so the geosphere interacting with the atmosphere. There's water in the atmosphere also. So when we look right here, oceans are 97%. Big 9-7. Ice caps and glaciers, that's 1.7%. Groundwater, that's the aquifers, that's just a 0.8%. Surface, that's lakes, rivers, creeks, ponds. That's just 0.3%. So this is 0.8%, this is 0.3%. It's less than 1%. It's not very much of the water compared to all the water that's in the world. And then lastly, the little bit that is in the air is 0.2. There's a joke behind that 0.2, but I'll maybe save that for another day. 0.2 right here. So we add these up, 0.2 and 0.3 is 0.5, 0.5, and 1.7 or 1 and 7 tenths and 8 tenths makes 2 and 5 tenths. Is that right? Yeah, 2 and 5 tenths. Oh yeah, so when we add that, 5 tenths and 5 tenths is 1 whole, decimal 1 whole, and 1 whole and 2 whole is 3 whole, and 97 plus 3 is, holy cow, Mr. Rhines, 100%. I know. Percents are based on 100. All right, hey, the last thing then. Can I go to the back side? Yeah, there's other stuff on here, but that's all right. I'll use a nice dark marker for this one. All right, so the last thing, Earth's fresh water. Fresh water, and you can see in your notes right there that out of that fresh water, if I looked at it, oh, I don't know, in a pie chart, let's say. Ooh, that marker is not good. It sat for 2 weeks without being used over at Willowbrook. So out of that, it's 69 and 524 thousandths, because it's 0.62524. That's going to be about half would be 50, 75, so it's about this much. About that much of it is glaciers, snow, or frost. This is out of the fresh water. So we eliminated the oceans and anything that's salty. Out of the fresh water, most of what we have in fresh water is frozen. Okay? Now, out of our groundwater, stuff down underneath, about 30% of it is groundwater, aquifers. We don't even see it. It's down underneath the ground. So all of this, frozen, ice caps or glaciers. And this amount is underwater. So that leaves all these little tiny fragments, little bits that are lakes, whoop, this little bit, or soil moisture. I can't even make it. That's like 0.05% of the water represented. Atmosphere, that's floating around in the air. Swamps, wetlands, rivers. It's all these small little amounts right here that take up the rest of the pie chart. I'll let you see it like that. So when we were looking over here, this was water, land, 100%. Most of it is water, a little bit land compared to all this what's showing on the surface of our Earth globe. Down here you can see salt. Most of it is ocean salt water. A little bit is fresh, still equals 100%. When we look over here, all of our oceans, ice caps, groundwater, surface areas, atmosphere, we add those up, boink, 100%. And so if we just take the oceans out and only take this fresh water, only the fresh water that doesn't have salt, and we make a pie chart out of it, like this, it's gonna be mostly frozen. A little bit of lakes, no, this was aquifers underground, and then all these little subsections out here is atmosphere and marshes, swamps, and lakes and rivers and things like that. Okay? The weird thing, out of all this fresh water, I mean, this is fresh water right here running behind Mr. Rhines. Out of all the fresh water, didn't my note say that only 1% of the Earth's fresh water is ready to drink? So out of all this, you could only take one little sliver. One little sliver of this would actually be drinkable. The rest of it, you wouldn't want to drink it. It would make you sick. And that's why, you know, earlier in the year when I ran that marathon back in the fall, I was running for Team World Vision, right? Remember my bracelet? And I showed you some stuff with that. I was running for clean water because there's a lot of water around, but that doesn't necessarily mean you'd want to drink it. In fact, it would make you sick if you did. Okay. Hey, I'll probably come back at some point with another video and maybe in a different location. I don't know if you can hear I-90. I-90 is right over there, and so it makes it a little loud, but it's just something different. So you're watching today, and I'll have you probably answering a few questions on this, and hopefully you learned a few things with Cora and I as we're out here in the woods. So take care. Be kind on April Fool's Day, because there's a lot of jokes going around that aren't so funny in the world, but you know what? Peace out. We still love you guys. Take care. And we'll see you along the way. We love you.